Good afternoon, good morning, everybody. Welcome to our latest session of the Community Cafe. If you haven't joined us before, we do record the session so that we can load them onto the website on demand afterwards. So if you do have a colleague who would be interested in watching, we will send the link out. If you haven't joined us before, we just want to make these sessions as a way for our customers and partners to understand a little bit more of the products, to understand a little bit more of the ins and outs of how you can work with the products, maybe a little bit easier, maybe a little bit faster. And we want to make the sessions as interactive as possible. So if you do have any questions, please either put them in the chat or in the question box, or at the end. We'd be really happy to hear from you in person. So today we're going to be talking about LoadTest. We're going to be talking about hints and tips for a successful LoadTest project. And with that, I will hand you over to Lee Balsam, who's our Product Strategy Director. Thanks, Lee.
Thanks, Rachel. Hey guys, so thank you very much for being part of the session, for attending this, and welcome also to our Community Cafe, one of our presentations in that series of presentations. My name is Lee Balsam. I'm the Product Strategy Director for DWS. And as Rachel said, we are here to discuss or talk about some hints and tips for what makes a successful load test project. I will try not to keep you for any longer than 20 minutes, and for that reason, I'm going to be moving quite quickly. And just as a reminder, we want to talk about, first of all, why do we load test our J.D. Edwards E1 system? Well, obviously, we want to reduce that unnecessary risk. If there is a high cost of failure, if the system all of a sudden starts running really slowly because some variable has changed within the system, higher number of users, what have you, and suddenly everybody's working a whole lot slower than they are able, then that cost escalates, and quickly. But also knowing your system's breaking point is kind of important information as well. How many you want to expand over the next 18 months, say, taking on a whole bunch of new users, you want to know how the system will cope with that. So providing assurance to key stakeholders, it's also ensuring value for money from those third-party providers, suppliers that promise a certain amount of performance from your gear. It keeps them honest, I guess. Now you can, should, and will do better than the old-fashioned way of doing load testing, which is dragging everybody in probably on the weekend and feeding them pizza, and you'll get some, fairly grumpy people at the end of that process. There's also some problems with that approach. I mean, it's obviously a massive investment of everybody's time. It's difficult to, I guess, accurately simulate load when you have real people doing their job, and you certainly can't repeat the same load, exactly the same load between tests. So making comparisons between two different load test results can be difficult under that approach. It's difficult also to easily simulate multiple locations around the globe simultaneously with that sort of with that approach. There's very little in terms of takeaway data, and of course it is something of a morale hit amongst staff. You wouldn't want to do that more than once. Yeah. So I think if we could sort of drill down to probably what is the most important aspect of load testing, and that is with this slide. It's in terms of making sure you define what is your success measures, what will make your load test a success versus a failure. So to do this, we're going to look at several aspects. We're going to try and figure out what it is we're trying to measure and monitor. Now, it may well be that there are some issues in the system right now, or suspected issues, such as performance bottlenecks. You may have some issues and you want to know where they are. So one of those questions would be where to test. It may well be a network issue, maybe it's users in a particular location, bandwidth is a problem. So answering that question, where should we make these tests run when we apply the load, could be relevant. But it also might be a bottleneck caused by some kind of functionality that you're throwing at the system, a particular application or a particular batch job, and that might have give the hardware a hard time, or the database a hard time, or the processor, or all of the above. So what to test is really key. What functional areas should you test? Peaks and troughs can also play a part, and that can come down to the number of users that you have and the type of users, whether they are low users, average users, or high, heads down, typing, clicking as fast as they can users. So who to test is really important. The areas that those users come from, parts of the business. Another what to test and how many times and for how long is that question about the functionality and duration in terms of peaks and troughs. Are there certain times of the day, week, month, or year that you start to see performance degrade related to possibly all of those aspects, the number of users on at the time, the functionality that they're running, and that it coincides with a end of month, for example. But instead of looking at it like that as possibly a problem that you have or that you're expecting to see, you could also look at it the other way around and sort of answer that question, how much performance can we achieve with the throughput aspect? So nominating or setting yourselves a target of the number of transactions per hour or the system response to user clicks. What are the minimum requirements we expect to see? Do our batch jobs complete normally in time? Do we have a particular set of jobs that have to finish within a set amount of time overnight, for example, to ensure that the next day's business operates correctly? Identifying the limit to the number of concurrent users. What is that point of collapse? Now, you might be sitting on a 500 users today, but you know that in 18 months' time, that's going to increase by 50%. Will the current system handle that? And if not, where is the problem? Do you need to upgrade your gear? And that relates to simulating that future growth, of course. Excuse me. So defining those acceptable failure rates, it's all part of that defining and measuring what is success. As that load rate increases, you may decide that some degradation in performance is justified and allowable, but at some point you're going to have to determine that at this point in time it is no longer acceptable. So answering that question, what can we achieve? And of course, as load tests run, you want to repeat load tests. You want to run them again and again. You want to compare. You want to then tune, improve. CNC sysadmin guys come in and make some tweaks and say, right, let's retest, let's remeasure and see how we get on. So what you need to know, well, Dimension Load Test is our product. It is native to E1. We designed it specifically for E1 and it works alongside the sister product Dimension Swift Test. I won't be covering Swift Test here. I'll probably mention it a few times in the session, but we won't be talking about it specifically, other than to say Swift Test is the area where it's our automated test script creation. So you create the test scripts in Swift Test. So this is the sort of the function areas that you want to test, and then those test scripts are referenced by Dimension Load Test. So Load Test is the sort of the overall controller to manage applying load by running those test scripts against E1. It is incredibly easy to set up and use. We've designed it in such a way that once you've got your Swift tests organized, creating a load test, running the load test is a really easy thing to do. And because of that, so easy to learn, the online training is very quick. It's easy, it's intuitive, it's powerful using that scripting tool. And because it is so easy, you can repeat the simulation of your loads. You can run a test, you can make changes, you can repeat the test, and you are getting the identical load from that functionality, who's testing, where are they testing perspective, answering those questions that we saw on that previous slide, and providing data for analysis so that you can perform that sort of tuning. Okay, so what I'll do is I'll have a quick look at the software. It will be a relatively quick look because it is so easy to use. So I thought we'd look at it from a perspective of answering those questions in red in that previous slide, the where to test, what, who to test, etc. Load test uses the concept of a controller, which is the software we're looking at right now. And it also uses the concept of agents. So the controller manages the agents. It's where you define a load test and where you can kick off that load test, and it calls or references those agent machines, and it's those agent machines that are effectively being those virtual users and running the load that's being applied to your system. So what we're looking at here is a series of agents. 2 of them are online right now, waiting to be run, but these are the agents that are available to us in this particular setting. So an agent really defines the answer to that question of where to test. For example, this agent here, DWS 001, is my own UK machine. It's in my UK office, sitting over there in High Wycombe, currently waiting, listening to be activated as a load test agent, simulating virtual users. This machine here is the laptop that's sitting in front of me in Auckland, New Zealand. They are 12,000 miles apart, these machines, both, if I kick off a load test, running the same test against E1 in the cloud via the Chrome browser, as your users do, but 12,000 miles apart. So therefore simulating that where around the world do you want to push the load onto your system from. Your agent machines can be physical, as I say, they can be located anywhere. They can also be virtual machines. These machines here are virtual, for instance. They can be in the cloud, so you can set that up accordingly and according to your situation. In addition to agents, I thought I'd just mention agent pools as well. Agent pools, really easy to explain. An agent pool is given a name, and it is literally a set of agents. That's all it is. The thing about agent pools is when we define the load test, in our load test definition, we allocate the agents or the agent pools that we want in that load. I could set a load test up with these four individual agents as rows in my load test definition. I could do it that way. But if I know that I've got a whole bunch of users, each agent can run somewhere up to sort of 10, 20 virtual users per. It depends on the spec of the agent machine, the physical machine. But if I wanted to run the same test functionality, the same test script against all of the agents on this machine and this machine and this machine and this machine, all four of those. So let's say that's 40 or 50 virtual users all running the same script. Then I could define them as a pool, as we see here, and then I can assign the pool to the load test. It's a more efficient way of defining those load tests. So let's have a look at what the load test looks like. So a load test, these are our load tests here that I've got defined in this environment. We might have, for instance, a load test that's a day in the life cross-functional, sort of a typical set of users doing a typical day's activities. You might have load tests that are more heavy usage, heavy load test of purchase order entry, for example. Particular day of the month, you have a whole bunch of users doing purchase orders. You might have monthly key jobs, payroll, for example, ultimately leading to what might be your ultimate load test, which is kind of like a worst case scenario, I guess. Worst time of the cycle, the most users, coinciding with end of month, coinciding with payroll, coinciding with time entry, all those things that can tear a system down or make it run a whole lot slower. But I'm focused on this particular load test, an example load test using individual agents. So here is my load test definition, and this is as complex as it gets, which isn't very. Individual rows in our load test representing the agents or the agent pool. In this case, they're all individual agents. What I'm defining here is what functionality, so this is the what to test question, do we want to for this load test to run? And in this case, we're saying this agent, I would like this test queue to run, the void journal entry test queue. Now, if we had a lot of time, I would jump over to Swift test and I would show you exactly what that test queue entails with it obviously voiding a journal entry. There's obviously some test script actions that it's running, but let's assume it's doing void journal entry for, in this case, 10 virtual users. And it's going to run this queue 4 times, one after the other. So if this was doing the void of let's say, if this queue was doing the void for, let's say, 2 journal entries, times 10 virtual users is 20, times 4 iterations is 40 individual transactions of this type from this one agent pool. But then this agent is running exactly the same queue in the same capacity. So that's twice as many. That's 20 virtual users across 2 different agents, wherever these may well be physically positioned. In addition, and simultaneously, we've got this agent running a slightly different test queue. So it's representing 8 users in this case, doing 3 lots of these, entering journals. And also simultaneously, we've got a different machine doing supplier invoice entry, times 6 users and 5 iterations. So that's how we can set our what to test, and also in a way defining our peaks, because we can nominate obviously how many users, how many iterations, and how much load to apply to the system. Other settings that we can apply out here to the right-hand side are some wait times. At the moment, all of these fields are set to 0, which means the system is going to run as fast as it can. There is no time between. As soon as the system is available, it's going to click the next button. It's going to enter the next field. But we can apply times, or you can apply times, milliseconds, to those various levels of wait times to represent kind of the human aspect. Humans don't do 8-10 hours a day, heads down, clicking as fast as they can. They chat to the neighbor, they have coffee breaks, all those sorts of things. So you can simulate that human nature aspect. That's a load test with agents. Here is a load test with agent pools. In this case, there is a single row. There doesn't have to be a single row. There can be multiple rows with pools. And indeed, there can be load tests with combinations of pools and individual agents if you so wished. In this case, if I click on our row, we can see this pool is made up of these agents. 2 of them are online currently. Our test queue that it's going to run, 10 virtual users per agent in the pool, giving us a total in this case of 40 virtual users on this row. And this is where the agent pool situation makes it easier to set up our load test. This is the equivalent of having 4 rows, each with an agent in here. The same kind of wait tests apply, iterations, etc. And then that's our definition. The time-consuming part, I guess you could say, if there was a time-consuming part, is making sure that your test queues are good, that they are valid test scripts, and that they run as individual tests, but then defining them as a load test, as you can see, is really straightforward. Once I've made that definition, we're all ready to go. System admin's standing by. We hit the go button, which is the execute button. I'm not going to do that here because it's a load test. It runs behind the scenes. There isn't an awful lot to see when it does that. But that machine, or the machines in this pool, will kick off, start loading the Chrome driver, running those tests in E1 as if they were physically users doing exactly that on those machines. When the test is finished, we can look at the execution results. And execution results, we can view it in different ways and means. We can look at it by test queue, by agent, see some stats about average times for login, for pressing the find button, etc. So some overall stats. We can also look at the execution detail. I'm going to go directly to the map. We can drill down through and see that for this load test, there was a particular agent. There's a virtual user and an iteration, only one in this particular case. The test queue ran 2 purchase orders. And this is where, when you're familiar obviously with E1, you'll start to recognize this. These are the test actions that ran in this particular script. Opening application, in this case P4310, hitting the add, supplier numbers, entering some, populating some fields. This is hard coded, of course, but they can be soft coded values. Hitting the OK and committing the purchase order to the system. Okay, so that's the use of the software. It's really straightforward. Let's jump back to our slide deck. There's a couple of other things I wanted to mention in terms of hints and tips. Who should be involved in these projects? Well, you've got it's definitely a team effort. You've got the functional team, the business analysts are the guys that tend to define what tests you want to run. What are the applications you want to test? Where are the areas that tend to put the most load onto the system. So they plan, they design the tests, ensure that they are appropriate to a load test setting. The testing team then convert those into those Dimension Swift test scripts, often the same people as the business analysts that design the tests, because DS is so easy to use. Then, of course, you have to have CNC, system admin, in the background, but also being involved, of course, providing that infrastructure. But as the tests run, monitoring the hardware, the database, the network, the processor, seeing how it's being impacted as that load applies to the system. And then obviously doing changes, making tweaks, rerunning, and keeping them actively involved in that manner. And of course, then you have project management coordinating the whole thing, accepting the results, and ticking the box that says, yes, the results are deemed acceptable. So the best approach in terms of load tests, then obviously identify the right environment that you want to run load tests over. Create load test friendly scripts. Some aspects, some load tests some test scripts that you run in Swift test as individual tests are perfectly valid tests in Swift test, but they don't suit load test perhaps. Things like time entry. You wouldn't want more than one user entering time entry at the same time for the same data, because you're going to have conflict. You'd want them, if you're doing that, you need to make sure that the test script is load test friendly by ensuring that the users are entering time entry data for different activity codes or different time periods, or whatever the thing is that makes those entries unique by each user. Obviously, adding transactions like journals or purchase orders or something is fine. You can have as many users as you like running those at the same time. Consider your data refreshes between tests so that the comparison between results is absolutely identical. If you want to ensure that they are absolutely identical and there isn't a data reason as to why one test and then another test is causing a disparity between results. Make sure that you assign your agents in realistic, both physical and virtual locations. And when I say realistic, I mean that it's relative to your organization's setup. Really key one, I guess, is starting small. The next 3 points kind of address this thing that I'm going to talk about, which is starting small and building up. It can be frustrating if you run a massive load test first, the thing starts to fall down. Not load test, the system starts to fail because you've hit it really, really hard from point one. Unpicking that can be a bit of a pain. So it's better to start small. And by small, I mean the number of users, the number of agents, the number of iterations, the complexity of the tests, of the functionality that you're running. And then once that's looking good, got a good performance coming out of that, then start to ramp up and build your load tests that way. It's always a good idea to add, when a load test is running, typically a bigger scale load test, once you've done that ramping up process, add live users, a real person or a few people to the system, and get them just to do their day job, just to give you that human aspect return feedback on how they feel the system is operating while this load is being applied to the system from other places. And those third-party monitoring tools, we don't intend to invent the wheel on this stuff. There are lots of products out there that your CNC sysadmin guys will know, and probably already currently have, that do that sort of monitoring of those other aspects, database, network, processor, etc. So use them and have them monitoring that stuff so that you can identify bottleneck locations during the run. And finally, the final slide, load test and things to avoid. We want, you definitely don't want to test applications in dev environment. This is partly related to the previous slide in terms of pick the right environment. You run into issues like running code that is really not yet properly tested, and you'll have failures for reasons unrelated to load, perhaps. Avoid testing. This is the whole kind of extrapolation thing. We see this time again with with clients or organizations who test parts of an application, parts of the functional areas, and then extrapolate those results to the wider application. If you run parts of P4210, don't assume that other parts of P4210 are going to give you the same results, because the functionality is more complex in some areas than others and takes longer. It is more complex functionality. And likewise, don't test with X number of concurrent users and assume X times 2 is going to be half as fast. Doesn't work that way. Yeah, don't extrapolate. Making sure that your criteria for success is well defined is important. Try not to test those obscure functional processes, and things to avoid, obviously, is not non-buy-in from those other aspects. As I say, it's a team effort. Lots of people, different people from different parts of the organization are involved. Not really lots of people, but different aspects of the organization. So definitely want buy-in from those roles. Okay, so thank you very much for being part of the session. Hopefully that has given you an insight into some parts that make up a successful load test project.
Yeah, great. Thanks, Lee. Yeah, if you do have any questions, you just have time to put one into the chat or put it into the questions box, or unmute yourself. That would be absolutely fine, and we can answer them. If you don't, we're very happy to finish the webinar there, and I think that was a really good overview of the things to avoid and also the things to include with that demonstration. So as I don't see any questions come in or any comments in the chat box, I'll just say thanks, Lee, very much for that really informative presentation. And with that, we will sign off.
Thanks all.
Thanks all. Thanks, Lee.